Hello, my name is Charlie Webb, and I covered pages 424 to 429 in the textbook, and I will be talking about hunger. So let's start with the physiology of hunger. So Ansel Keys did an experiment in 1950 about semi-starvation, where 200 volunteers were studied and they were all given normal food intake for 3 months. Then, after this 3-month period, 36 volunteers were limited to half the food intake after the 3 months. And then he wanted to see what semi-starvation did to a person. And he found that they would become listless and apathetic. And he also found that they would have a reduced body weight. In fact, they maintained 75% of their body weight after being semi-starved, meaning that they lost 25%. And then these effects occurred because the homeostatic system that maintains their normal body weight and sufficient nutrient supply was telling them to eat more and gave them the feelings of hunger. So now let's move on to figure 11.4, which is Cannon and Washburn's experiment of stomach pangs. So in this experiment, Washburn was required to swallow a balloon and which was attached to a recording device. The balloon would inflate in his stomach and then transmit his stomach contractions. So whenever he felt a hunger pang, Washburn would press a button which would determine if there was a correlation between stomach contractions and hunger. And they found that he was in fact having stomach contractions during his hunger pangs and whenever he felt hungry. And then in Seng's rat experiment done in 1938, they tried to contradict the findings of Cannon and Washburn. So what they did was they removed the stomach of a rat and then connected it directly to the small intestine. And this would determine if hunger was caused by the stomach or if there were more factors that were involved. And the results were that Zhang's rat would still eat and he was still hungry, which means that there were more factors behind hunger. So now that we know there are more factors, let's move on to body chemistry and the brain. So hunger hormones are another one of these big factors, and you can see there are a few that I've listed. So insulin is a big one. It reduces the blood sugar after food intake, and you may know it also causes diabetes if you have a lack of this, if there's a issue with your pancreas, which produces your insulin. And then orexin is created by the hypothalamus, which stimulates hunger once the blood sugar drops to a certain level, because you need to have a balance between your blood sugar. So the insulin gets rid of it, and then the orexin tells you to put more into your system and have a balance. And then ghrelin is a hunger hormone that is produced by the stomach when it's empty. And this hormone was found to be in Sang's experiment and was observed in Cannon and Washburn's experiment because they were feeling hungry because of the stomach. So that was the factor behind those experiments. And then you also have leptin, which is produced by fat cells when they're abundant and signals the brain to increase metabolism and decrease hunger. So this essentially tells the person to eat less so that it can lose the abundant fat cells and keep a certain weight within the body. And then you have PYY, which is produced by the digestive tract and sends signals to the brain telling it to stop eating, which also contributes and goes hand in hand with leptin so that they lose weight and lose the fat cells. And then there's also the set point, which is also kind of referred to as a weight thermostat. So the set point is an interaction between all of these hormones and brain activity that explains how the body maintains a certain weight. So this can also be altered if a slow, sustained change in body weight occurs. So if you make a conceited effort to lose weight and you stop getting a lot of nutrient intake, you can alter your set point, therefore losing weight. And then there's also the basal metabolic rate, which is the rate of energy expenditure within a person, and it's the energy that is used to maintain basic body functions. So this was found in the semi-starved experiment, where the people in Insel Keys' experiment were able to maintain their weight because of a 29% drop in their basal metabolic rate, which is how they kept their set point close to their weight. If the metabolic rate hadn't dropped, then they would have just kept losing and losing weight. So that concludes that section. Now we'll move on to the psychology of hunger, so psychological effects that contribute to us getting hunger. So Paul Rosen did an experiment on amnesia on hunger in 1988, and he had 2 amnesia patients, and he offered them a meal every 20 minutes. Now, since these patients had short-term memory loss because of their amnesia, they couldn't remember eating and ate up to 3 meals after the 20-minute intervals. So he just kept giving them meals and they kept eating. So this proves that knowing when to eat is based on the time in between our meals. So if we can't remember eating, then we will just eat anyways. So that's a contribution to our hunger. Now we'll move on to the biological taste preferences as well as cultural taste preferences. So emotions can impact our taste preferences. Studies have shown that people who are depressed might crave starchy or carbohydrate-filled foods because they will release a neurotransmitter serotonin, which relieves and calms down the person. There's also an experiment done on stress eating, which shows that rats and many humans enjoy eating Oreos. So if you're stressed, you might find an urge to eat Oreos. So that's a taste preference correlated with stress. And then there are also preferences that are acquired through sickness. So if you get sick because of a food, it'll create a disliking for that certain food and you won't want to eat it anymore. There is also cultural influence. So North Americans and Europeans will generally shun horse, dog, and rat meat, which is valued in all other places. I think anybody in the U.S., if you ask about horse or dog meat, they'll generally say that it is not okay to use those types of meats in foods, whereas it's the exact opposite in different cultures. And there's also the factor of neophobia, which is essentially a dislike of unfamiliar things. So we will continue to eat the foods that we are familiar with and we know we like and we know it won't get us sick. There is also a factor of pregnancy. So food aversions will peak when the embryo is most vulnerable to toxins. So essentially it's the embryo's way of telling the parent to not eat toxic foods, so they will tend to avoid certain foods so that the embryo can survive. Now there's also situational influences on eating. So there's a study done by Herman and Hetherington, and it was on parties. So sometimes we might find ourselves eating more at parties or overeating and becoming extremely full. So why does this happen? This happens because our natural behavior tendencies amplify when others are around. So if there are other people around us, we will tend to eat more, which is why you might overeat at a party. Now there's also the factor of food variety, which increases our consumption. So there are some historical factors within this. Our early ancestors would eat more food when there's variety and abundance. So this would give them vitamins and minerals as well as fats to help them survive winters and famines. So it would essentially build up their weight so that they can afford to lose it in case there's a famine. And then this explains why we'll eat more at buffets that have variety, just like our ancestors once did. So that's it. This concludes the hunger presentation on pages 424 to 429. Thank you for listening.